So they give us an interesting graph, and they tell us that it was reflected in the x-axis, and its image is shown below. So what we see here in the green box is not the graph that we see. We see the graph after it was reflected in the x-axis. So if we wanted to know what did that original graph look like that's in the green box, we would have to undo the reflection in the x-axis. And so we could say, well, our original green graph looked like that. And it was reflected in the x-axis, and that is what we see as the red graph. Now, we want to find out what is the equation of the red graph. And what I've been showing some of you as I've been coming around and doing some help is sometimes it's easier to use function notation than it is to use, especially in this case, we've got a very complicated equation to start with. So if we simplify this and I rewrite this green equation in function notation would look like this. And our red equation is what happens when there is a negative outside of our function. Because what's happened is our y values, when we flip over our x-axis, our y values have been multiplied by a -1. For example, on our original graph, can you see that you have the point 0, -2? And on our red graph, we have the point 0, 2. So it's our y values that are getting multiplied by a -1. Things that affect our y values are outside of our function. So if we wanted to write our equation of our red graph, it's going to have a negative, and f of x, all of f of x, and I'll put it in brackets here, is what we started with. So I rewrote what we started with a negative outside of the graph. If I wanted to simplify this, what happens when you multiply a fraction by a negative? Let's say I have another fraction. Let's say I have 1/2 and I multiply it by a negative. What are all the different ways you can write that? Well, sometimes it's just written with a negative out in front like that, right? -1/2. You could also think of that negative out in front as a -1, and you could write that as -1/2. Have the negative on the top of the fraction. Or, if I'm thinking of this as a -1, and I write -1 as a fraction, can you see that you could write -1 by having the negative on the top? Or you could write -1 by having that negative on the bottom of the fraction. And if the negative was on the bottom of the fraction, you could write this as 1/2 as well. So working with the negative out in front of a fraction, you can either write it with the negative out in front of the fraction, or you can think about multiplying the top by the negative, or multiplying the bottom by the negative. But a mistake that sometimes happens is people multiply the top and the bottom by a negative. And the problem with that is if I multiply the top and the bottom by a negative, I'm actually multiplying by a +1 instead of a -1. So you undo what you were trying to do. So now, when looking at this equation, and all of those answers would be right. They wouldn't mark it wrong if you left it like this. They wouldn't mark it wrong if you put the negative in the top of the fraction. They wouldn't mark it wrong if you put the negative in the bottom of the fraction. Personally, if I were to write this out, I would multiply the negative in, and I'd multiply it on the bottom because it gets rid of a lot of negatives. Like if I multiply that negative on the bottom of my fraction, I'm going to get 2x² plus 0.5. And that looks cleaner than having a whole bunch of negatives in my equation. but any way that you would write it would be fine. Now, I just want to do some imagining what happens to the equation if they told us the other reflection. So again, using the function notation, if my green graph is f of x, what would happen if I thought about f of negative x? If I took my green graph and reflected it over, I'll write y equals, over the y-axis. Can you see if you reflected it over the y-axis, it would have stayed the same. How do you write the equation, though? Because it doesn't always stay the same. In this case, it stays the same. The equation's going to be the same, but we're going to see why. Because if I write f of negative x, in function notation, this means wherever you had an x in your original equation, you should now write a negative x instead. So if I was doing that, I'd have negative 2. Where I had the x, I'd write negative x instead. It's still going to be squared minus 0.5. What happens when you square a negative? Becomes positive. So when we simplify this, we would say, oh, that's why it stays the same. I can see it graphically that if I took that green graph and reflected over the y-axis, it would stay the same. And now I can see algebraically why in this situation, when I flip it over the y-axis, it stays the same. They even have a special name for functions that if you flip over the y-axis and they stay the same, they're called even functions. But you don't need to know that, but it's just interesting. So anytime you reflect a graph over the y-axis and it doesn't change, it's called an even function. And anytime you reflect a graph over the x and over the y, and it stays the same, that's called an odd function. Well, the negative 2 times, you can't do order of operations, right? So we have to square before we multiply. So we square the negative first, making it positive, and then that positive gets multiplied by the negative 2. So it does stay negative 2x squared. Okay, so the last set of questions we're going to do, 7, 8, 9, and 12.